Okay, our last video for 4.1 is going to talk about empirical probability and how to create different conditionals looking at a contingency table. So to get started, it says if our sample is representative of the population, then we can also interpret a percentage we calculate from the contingency table as a probability. And so this is we're going to go deeper into this idea in the next section. That's also known as the likelihood that something will happen. All right, since a contingency table is constructed from data collected through sampling, right? All of our examples have been like a survey says, right? We're going out there in the field, we're getting our hands dirty, we're talking to people. This is also known as an experiment. We can call it an empirical. And so what that means is when you are getting probability from doing hands-on experiments, like talking to people out there in the field, taking data, it is exactly what you're witnessing. That is known as empirical probability. All right, and we'll talk about the difference between another probability in the next section. We call this empirical probability, or it's also known as experimental probability. I like to think E goes with E, right? So if I'm doing an experiment, I'm doing a survey, whatever I'm doing, and I'm just stating the data as I witness it, that's known as empirical. Now, to write probability, we have to know a certain notation. So it's, we're going to use probability notation. Okay, so what I mean by that is when you're stating the probability, we state a big P, okay? That stands for probability. And then in parentheses, we put what we're finding. So this, if I were going to read this, it says P of, so it's like that function notation, if you can remember from Math 95. But really, I would say this is the probability of, and whatever we'd be finding, right? The probability that people like coffee. This is just a shorthand to write it. Now, either this will produce a fraction or a decimal. And this is important. Just be careful and pay attention to directions. So my open math, they go back and forth on you. So make sure you're just reading the directions carefully. Sometimes it'll say, tell me a decimal to the third rounding place. So make sure you're just rounding where they say, because it does change throughout the lesson. All right. There are three things I want to cover, and then we'll do an example. This is an and probability, and that means when it's just like your truth tables, when the things happen at the same time. In other words, to compare it to the truth tables, is they have to both be true in order to be true, okay? So the and is where they are both happening. Where the or, again, just like your truth tables, it's inclusive. And what that means is, refresher, is that either one is happening or the other one's happening or both of them are happening, okay? This is something you want to be very careful with overcounting. That's a big mistake we make. Now, given is the probability that a characteristic is present knowing that another characteristic is present. And so what I mean by that is, so again, I'm going to read this as not PT given coffee, okay? You're going to read that as the probability of tea given coffee. This is the probability that a participant likes tea given that we already know they are a coffee drinker. And so what that means is these are the denominator is the grand total, where with given, your denominator is what the given part is. This will make more sense once we actually do an example. Is. Okay, so let's kind of tuck that away in your memory or your brain. Maybe you don't have it memorized yet. That seems a little unfair. And let's put it to use. So our last example says, use the contingency table for the results of the beverage survey to find the following. First, find the missing value in the table. So this is similar to my open math. They might give you a table that's not complete. Well, you can find this missing piece by either realizing, well, 60 minus the 20 gives me 40, or 95 minus 55 gives me 40. So it should give you the same result. Okay, now we can start. So it says, what is the probability and percent that someone likes tea? So I'm going to look in my tea row, and it looks like the total amount of people that like tea are 60. So again, I'm using notation, probability, and maybe I can say tea, or I say likes tea. However much information you want to give is up to you. Well, it's going to be 60, and remember, it's out of the grand total. So that is it as a probability. Now that's like saying if they wanted it as a fraction. Now, if the instructions say they want it as a decimal, in my calculator, I'm going to do 60 divided by 150, and I get 0.4. Well, I know how to convert that to a percentage. I hope you all do too. And so it would be 40% of people like tea. So again, it all depends on how the question's being asked. So if they want probability, I would list this. If they say I want a decimal, I'd list this. And if it said I wanted percentage, I'd move the decimal place 2 places. All right, let me get rid of this so it doesn't confuse us. Now it says, what is the probability that someone does not like coffee? So I'm going to look in my no coffee column. So probability doesn't like coffee. Okay, well that'd be 55 out of your grand total. I didn't ask for percentage. I didn't ask for a decimal, so I am fine. I can just leave it like that. C. What is the probability and percent that someone likes coffee? Okay, here's this piece. Or I read it backwards, likes tea and coffee. So I'm going to say probability, tea, and coffee. So I need to find where these overlap. So where do tea and coffee intersect? Right here. So that's the only place, because remember, they both have to be true. So that'd be 40 out of your grand total, which is 150. Now, if I wanted this as a percent, I'm going to go to my calculator and do 40 divided by 150. I'm going to have to round this, so I'm going to use rounding symbols. And I'm going to say 0.27. And as a percentage, 27% of people like tea and coffee. The other thing I want to mention is when you do your write-ups and your work for your exams, you want to make sure you're stating your answers like so. Okay, so make sure you're good with notation. That's a big piece of mathematics. D. What is the probability that someone likes coffee? Ooh, here's this fun one. Given they, gosh, I keep doing that, sorry. Likes tea, given they like coffee. So I'm going to say probability tea given coffee. So you can write it like that. I just want to show you another symbol. Probability tea. It's like this long slash. That's a shorthand. I'll never test you on that, but they mean the same thing. Given is just this long line in probability. So this is what I was saying earlier. This is now your denominator. Okay, so I'm going to look at my total for coffee. Here's the coffee row, or forgive me, column. Well, there's 95 people total that like coffee. Out of those people, though, who like tea? Oh, it's just these 40. So it's like this is making you narrow in, okay? So the given is no longer looking at everybody. It's narrowing in what you're looking at. So, and it didn't ask for percent, it didn't ask for a decimal, so I can leave it like that. E, what is the probability someone likes coffee? So order does matter, and I almost messed it up on that last one. Coffee, given they like tea. So what that's telling me is I just want to focus on my tea area. So here's my tea area. How many people like tea? 60. Out of those people, how many like coffee? 40. Now, I can say, or I should say, you can leave it like this. You could also reduce this if you wanted to. There is something nice of leaving it like this because then you clearly see how many people we're talking about. Again, just pay attention to the instructions, okay? So it might say reduce your fraction, and it most likely won't, though, because probability, we like to see the full picture. Okay. So the last little example I have to show you is the or piece, and this is where the issue of overcounting can sometimes happen. What is the probability someone likes tea or coffee? Okay, so I'm going to go to my chart. There was no given piece, so I don't need to focus somewhere. My denominator will be all of it. So I know my denominator is 150. Now, tea or coffee? So here, they like both, right? So remember or, it's either they like one or the other or both. Here they like both. Here they like no coffee, but they only like tea. And here they like coffee and no tea. This does nothing for me because this means they like neither. So I don't want to list that. So what I'm going to do with those three things is add them. So I have 40 plus 20 plus 55. If I add those all up, I get 115 out of 150. Now here is the thing, if you're like, wait, I wanted to do it a different way. You do have that option. It just creates some problems because some of us want to say, okay, well, 60 people like tea and 95 people like coffee. So that should give me everything. And if I do that, though, I get 155, which is very different than 115. The problem is you have counted 40 here and here. So you've overcounted. So if you want to do it this way, then you have to also take away 40 because you counted it twice. That is a very common mistake. So I really want to encourage you to just look at individual cells. So just say, okay, here I want to add this one, I want to add this one, and this one. So you don't overcount. Okay, let me know if you have any questions, and I'll see you in the next video.